Hi, I'm Federica Rosso. I am an architectural engineer, and now I'm conducting research on the topic of urban areas and buildings and how they can improve resilience in cities. And first of all, I would like to thank Professor Ceccarelli and ELAUD for the invitation to this interview. I am currently conducting research at Sapienza University of Rome, Engineering Department, and today I would like to discuss with you some of the major stresses and shocks that we are studying related to urban areas and to cities. In particular, we are focusing on Mediterranean cities, but I will also present the case, for example, of another big city in another continent, for example, New York City. So I'm based in Rome, but I also conducted periods as visiting research scholar at New York University. So I also had the experience to work as a researcher in New York City. And many of the challenges that characterize Rome are also present in New York City. So today these are my two fields of study. And the two shocks and stresses I would like to focus on are related to one, urban heat island and heat waves, and then the second is related to flooding due to extreme precipitation events which are increasingly common in urban areas. So less rain all along the year, but all the rain comes together in very few events that are very intense and then that cause a lot of issues for the safety, well-being and livability of our cities. We had the experience just 2 days ago in Palermo, for example, where there were a lot of problems with a very heavy rain which posed serious challenges to the city. And so, first of all, urban heat island. Urban heat island, what is it, urban heat island? Urban heat island is a phenomenon for which temperatures in cities are higher than those in the close suburbs. And this happens because of many factors. All these factors are related to urban areas and to their configuration and composition. So, for example, the materials composing urban areas. There is scarce green, so not many parks, not many green areas, not so much grass, not so many trees, and this diminish the evapotranspiration, so the natural water process in urban areas. And on the other hand, we have a lot of asphalt, a lot of cement, a lot of materials that absorb a lot of heat. Thus, the temperatures in urban areas are warmer, are hotter. So, especially during the warm season, and this is an issue for example, the summer season, the warm season. All of us living in Mediterranean areas have experience of very hot summers. And these are due not only to urban heat island, but also to heat waves, which is another phenomenon that is exacerbated in urban heat island. So the two phenomena are strictly related because heat waves are worst when there is also an urban heat island. And the heat waves, we all have experience of heat waves with strange names, which are advised also in the news. So heat waves and urban heat island cause people to use more energy. And the more energy we use, the more the emissions we cause. And the more the emissions, the higher the urban heat island and the higher the temperatures. So this is a negative cycle that in some way we have to try to interrupt. And how to do this? the built environment itself can provide a mitigation for these two phenomena. And in particular, I would like to present two main ways, two main strategies. One is related to buildings, and the other one is related to urban outdoor areas. So we can mitigate such challenges by means of a conscious design, by employing determined materials that can help tackling urbanite island and heat waves during the warm season. I am especially referring to cool materials. So cool materials are materials that reflect the large part of the solar radiation, of the incoming solar radiation, instead than absorbing it. And this causes these materials to maintain lower surface temperature, and thus if these materials are employed as building envelope or as urban paving, we have a cooler building in the inside and we have a cooler outdoor temperature on the outside. Such materials are, we all have experienced cool materials. For example, marble. When you see a marble material, that is a cool material. So we all have experienced that if we touch a white, clear, smooth surface, it is cooler than a closed asphalt or dark surface. So this is how cool materials work. And there are a lot of studies, and we also conducted studies on this topic, quantifying the benefits of cool materials when they are employed on building envelope, on both on the vertical envelope and on the horizontal envelope. And such materials can also have determined interesting features, such as, for example, they can be colored by means of the addition of specific pigments that optimize the reflectance, not in the visible part of the solar spectrum, but in the near infrared part of the solar spectrum. So by employing these materials in the urban areas, both on buildings and on urban pavings, this is an easy and not so expensive solution to tackle urbanite island and heat waves. Then the second solution is, of course, the employment of more green in cities. I am talking about green roofs, green envelopes, and the addition of trees on the streets, on permeable paving, and this last solution is strictly related to the next issue, next stress that I'm going to talk about, and this is stress related to flooding, so to extreme rain events, and such an amount of water is not predicted. Thus, the infrastructure system is not designed to receive such an amount of water. So this water remains on the top of the urban land, so on the streets, on the sidewalks, and it constitutes runoff. And runoff is water flowing on the streets, and it can be dangerous for people, but it also can be detrimental for the well-being of people using the city. So how can we fight? How can we help mitigating from flooding events in urban areas? One of the solutions is the same that we discussed a few minutes ago about urbanite island mitigation. It is the addition of green areas and greenery both on buildings and on streets. By working on the urban surface and making it more permeable, we can reduce the runoff, and we can thus reduce the risk of inundation. Of course, all of these strategies have to be concerted, have to be designed together, because, for example, as we saw, the strategy of urban greenery is effective both to tackle flooding, but also to tackle urbanite island and heat waves. So there are many strategies that we as researcher in the architectural field, and as designers and urban planner can use to mitigate the challenges characterizing urban areas. And these are just few examples. And in Rome and in New York, we were studying in the last years all these kind of solutions. And in New York, for example, we were studying a lot of small parks that provide both permeable paving and also comfortable places where to stay during an heat wave. And all these strategies are defined as passive strategies because they are linked to the intrinsic characteristics of the built environment. So conscious design and urban planning can help mitigating and could have a tremendous potential effect in mitigating such challenges for urban areas. So this is my my view on the challenges, shocks and stresses characterizing urban areas. And this is even more true in this period where the built environment has become more and more important to our lives. We spend a lot of time in buildings due to lockdown, so having cooler buildings that consume less energy and at the same time allow improving indoor comfort is very important. At the same time, it's very important to have greener space just outside our home where we can go even very fast. So very close green areas, and many green areas, more green areas could be helpful also in mitigating such issues. So I hope this interview could offer a point of view, a perspective on how passive strategies and the conscious design, a conscious urban planning could help mitigating such shocks characterizing urban areas. Thank you for your attention.